SSL, TLS, man-in-the-middle situations in a network security architecture. First of all, you would try to identify the client. A client is often communicating with another client on the network, and they are having a communication that includes sending packages between each other. So for now, we're just communicating. What happens is that often we communicate with the router, and the router intercepts this communication and is able to forward this to other clients on the network. So therefore, it is called the router, and the router will handle the routing the network traffic and the communication between clients in a network. Sometimes we also segment these networks, so we get a better seeding and a better control of who is actually on the network and can potentially allow and disallow certain clients on the network. So this is often seen in larger corporations where you have many different several segments, including 50, 100 clients, workstations, servers, etc. that are included in these segments, and they are often bound by routers, and they will have firewalls in between them to control which kind of traffic goes in between them for security reasons. So here we have an example where we see the sales is on a VLAN. A VLAN is a logical separation of the LAN network, and they are situated on the VLAN 020, and another one that is the dev service, they are on the VLAN 060. So when we need to communicate with each other on the network, we will have to use the router. Often the router is used to communicate, and the router is here in this case R01 and has an IPv address 192, 168 and 0.1. So this is a very standard, a very generic router configuration used, or IP address used for configuring routers. Another case, we will have the workstation here, workstation 021, that has another IP address 192.168.20.3. So, and why do we separate, or why do they have different kind of numbers regarding to the position in the IPv4 address? Well, we see that this one is 20 because the 20 is a way of separating and logically splitting up segments on the network, so we can control the networks and how many clients are allowed on a certain network. This is used for security reasons and better managing networks. So, and this is another topic. So also we have the dev server with a client that is 172.16.60.1. So what is common here is the 60 and the 20 here for the VLANs in regards to the number of the VLAN and the seed annotation of the IPv4 address for the clients situated on that VLAN. Here we have a basic IP package here, where we can see that we have the source IP, the destination IP of the two clients that we are having on our internet or our communication here. So this is an important information because this is what we're going to be looking at when we are considering a man-in-the-middle attack. So it is important to have these IP addresses because the IP addresses tells us ultimately who we are trying to send a package to on the network. So in this case, we are trying to send a package from the sales network, the IPv4 192.168 and 20.3, and we're trying to send a package to the destination 172.16.60.1, but we're not aware of what hardware type, hardware address, flags, mask, etc. These are needed to be able to establish the communication between the two workstations clients on the separate VLAN. So we will have to ask the router of who is we will broadcast and we will try to find out who this destination IP who has this. So we will try to send out, and we'll wait for a response in order to know what hardware address is on this IP address. So we send out, and what we will use the ARP protocol to communicate with on this. So we will this address will send us the MAC address, or the router will send us the MAC address of this, because the router handles in this situation has the information that we need for communicating with this and finding and communicating with this other workstation. So it will send us now, after asking who has this, it will send us the MAC address of this workstation to and we will now be able to craft a package where we can send that correctly to the right receiver. And we will just fill out these blank spaces with the correct information. And we are actually able to look at this more technically. So now we will try to see an example where we try to find this ARP table that will allow us to identify the right hardware MAC address and the associated IP address, which is located on our workstation here. So we have an ARP table on the actual workstation here. We see that for the source 192.68.0.1, and we see an ARP table here. This is an ARP table, and we can now identify. We can see that we have associated addresses to the left. We have Ether as the hardware type, and we have the hardware address, which is the MAC address here. So we see this as we did before from the table. So what we're able to here is that we can write some code using Scapy for packet crafting, and where we can demonstrate that we can actually manipulate with this using this code to both get the right information, and we can send out and intercept other communication, and we can spoof. We can say that we are somebody on the network if we have the right information about the clients on the network. So this is a basic way of getting the MAC address from an IP address for the associated IP address. And when we have the MAC address, as we saw before, we are able to send communication to this other client. And this is what we are actually abusing this kind of protocol, ARP, address resolution protocol, to spoof another, to be able to spoof the another client, the gateway here, and so we'll be able to intercept the communication that is going from the laptop here, and between the gateway. So the gateway will think that we are a laptop, and the laptop will think we are the gateway. So by that way we can actually get information from both sides, or we can also get from one side. So let's try to see what we're trying to do in a more visual way. So what we're trying to do is to want to place ourselves between the communication and intercept and eavesdrop this communication by using the Scapy code. So here we use the method we had before for getting the MAC address. So we will know the IP address on the network. So we will just try to send. We'll get the MAC address and then send as if we were the computer here, and we will try to tell the computer here that we are this gateway. And in the other way, we will also try to tell the computer that we are the gateway. So first of all, we will try to tell to the computer that we are the gateway, and now we will tell the the gateway that we are the computer. Yeah, so we will try to mix around, and this is simply by using this kind of code here and combined with the other code showed before. And here's a more practically inspection where we can see that we are actually able to swap out the MAC address for this for this one. So here we have said that so before you saw this, this could be perhaps the attacker. So first we see that the attacker has this hardware address, and now perhaps this was the router, and now we think now the computer here, the client we are talking from here, is thinking that we are actually not who we say we are. So let's look at it again here. We have first this entry, and now we've spoofed. So now this IP that could be the router here, this one, has now got the same one as this one below. So now you have two similar hardware addresses. So this could perhaps be the attacker now says that this is this hardware address, and now intercepting the communication here. And now here there's a more pre-configured script or module for Linux here, where you can actually here use this interface, either null, and then you are able to intercept the communication by using ARP-spoof, which is a part of Kali Linux. And now you're just changing the IP addresses. So let's try to look at a way that we can perhaps secure us against this ARP spoofing. So what is important here is that we are using HTTPS for the application layer. Now we were looking at the OCI model, and then now we are trying to 7-layer model. So now we also ensure that we're using TLS for communication, and we also at the layer 5 we're using sessions authentication. TLS helps secure these sessions. The transport layer we use TLS uses TCP. So and the network layer there's no TLS. So this is what our weakness is. So basically TLS is this is described through these steps. So the first step is the client hello. We send a cipher suite, and then the other side responds with the chosen cipher, sends back a certificate, and then there's a key exchange and agree on the session keys used for this session of communication. And now the communication line should be secured with the certificate. So a way we can set up the certificate is using this open SSL. So we'll generate this kind of certificate, and we can set it up using this command also. So using these commands here, and I think we're trying to just set up the communication here and setting up a proxy. So this is a way to to intercept the communication actually. So this is also another way that can misuse the TLS communication here. So setting up a unconfigured certificate here. So we're setting up for this proxy here on this address 01010101 port 448, and now we can intercept actually HTTPS traffic. So that's another vulnerability here where you can use the SSL split to intercept communication here. And here we are showing that we are able to listen to the communication between two clients. So that's important to use the correct SSL and ensure that you're using a secure communication and you don't communicate with somebody who has self-signed SSL. So a way we can protect against also TLS communication that can be misused is to manually assign IP to MAC addresses. So we are not. This is actually mostly for ARP spoofing, and we use dynamic ARP inspection. We configure access control list on switches to use the specific IP addresses. So that is why we are segmenting. That's why we are using segments to ensure that we have full control and visibility of who is on our network, so we can easily see what is deviating and if there are any hosts and prevent hosts from connecting that are not allowed to be on the network. And we also ensure that the perimeter is so close down to the host-based firewalls for communicating gracious ARP messages with information and encryption. That is